Okay, shall I? Next thing, they will provide you the area, the values. We will try to understand that thing. So write the heading, area under graph. Area under graph. The next heading is area under graph. Let us say example number 1 for that one. Okay, consider velocity time graph is given like this. Okay, consider Vt. So this is your velocity and this is your time. Got my point? They will provide you the values like 10, 20, 30, whatever the values is. Let's say 20 meter per second. So what is the velocity at the t is equals to 0? What is velocity? 20 meter per second. Is it moving with constant velocity? Yes. Then velocity decreasing? Yes or no? In positive direction. Then again it is increasing with value in negative direction. Then again decreasing to 0. Then increasing in positive. I got my point? We already know how to read the graph. If I say, let us discuss with time period. So 0 to 2 it travel with uniform velocity, and here the time is 4. Consider here the time period is 6. Then here the time period is 8, and consider here the time period is 10. Okay. Generally we know about what is V. V is nothing but dx upon dt. V is generally dx upon dt. Can I also write this as dx is equals to v dt? Can I? If I integrate that, then I will be getting what? Displacement. Yes or no? So can I say that area under the graph, area under, can I say Vt graph? This is your velocity time graph now. So area under Vt graph will always provide you, what? Displacement. First thing, that is what? Displacement. How it will provide you the displacement? The area above the line. If you add all the area above the line and subtract the area which is below the line, okay, above minus below area will provide you displacement. Okay, and it also provide you distance also. If I add the area, above area plus below area, then it will provide you what? Distance. Okay. Then third thing, we can also find acceleration from here. Let the question be find the distance, displacement and acceleration from this one. Okay. First I will do one, you do the next. Okay. Now this one is 20 and this one is 2. That is 20 into 2. That can I say this one is 40 meter per square. Sorry, 40 square meter area. And again you will be having a right angle triangle. So this time period is 2. The height is 20. So this becomes 20. If this is 20, again can I say this is the negative velocity here. If I stretch this, then you will be getting this as minus 20. Yes or no? It is moving with constant acceleration. So value will be minus 20 here. Then this area is 20 again. This area is also 20 and this area is 20. Got my point? Okay. What is the displacement now? Can I say that 40 plus of 20 plus of this 20? Yes or no? That means total 80. 80 minus of this 40, answer will be your 40. Yes or no? Displacement answer will be 40. And if I ask you the distance answer, then the same answer is 40 plus of 20 plus of this 20 and this 20. Adding everything will provide you what? The distance. Now what is the total distance? Can I say 120 will be the distance. Now similarly we need to calculate the acceleration. Okay, from here to here velocity is constant. Yes or no? But from here to here, can I say that at this point velocity becomes 0? Yes or no? So at this point velocity is 0. If velocity is 0 here, what is the velocity here? 20. So 20 minus of 0 divided by total time taken is 2. That means can I say acceleration will be 10? That means minus 10. Yes or no? So we will substitute these things in xt and at graph. Let us try to understand how the graph is coming and how the values are represented. Okay. Now, so let us move to xt first. Okay. So initially it is moving with constant velocity. Whenever the velocity is constant, then xt will be provided with a straight line. Yes or no? So straight line now. Okay, so let us name this as A, this as your point B, this as your point C, D, this as your E, and this as your F. I got my point till here. Okay, so origin as it is, this is your A, this is your B. Body is moving with constant speed or velocity, and xt will be represented like this. Yes or no? Okay. Then what happened from B to C? Velocity is decreasing. Velocity is what? Decreasing. At this point, velocity becomes 0. Then it continued in the negative direction. Then can I write like this? From B to C, here the slope becomes 0. So at this point, velocity is also 0. Then from C to D, then I continue this like this. So this is your point D. So we reached here. I got my point. Then again, velocity is again decreasing, increasing. Decreasing. So from C to D, velocity increased. Then from D to E, velocity is what? Again decreasing. Again decreasing. Then can I draw this as like this? So at this point, can I say what is the point name? E. So at E, velocity again become what? 0. Okay. इसको ऐसा रखेंगे. It will look excellent. So this is your E, this is your, E, D. Over, then from here, from again velocity became 0. Now the body is moving in the positive direction. Then can I continue this as like this? Now what is the point name? F. Now let us try to understand this graph. Then how to represent distance also in the graph. So generally from A to B it moves with constant speed or velocity, then again decreasing, then from here to here increasing, then again decreasing, then increasing. Yes or no? Okay. Now how much body traveled from A to B? 40 meters. That means, can I say from here to here body traveled with 20 meter per second in 2 seconds, then can I say this as 40? Yes or no? Okay. Then again from B to C, body started to decrease the value and it traveled how much? 20 meters. So can I say from here to here, again if I add this 20, then this becomes 60. Yes or no? So this is happening for 2 seconds. This one is happened for 4 seconds. Yes, and this one is happening for 6 seconds. This one is 8 and this one is your 10th second. Are yes or no? So this is the representation of the displacement. Now tell me how many times velocity became 0? Can I say 2 times? One, velocity became here 0, and the second time velocity also became 0 at this point. Now, so here also velocity became 0. I got my point. Then again it increased in the positive direction. Okay. Are yes or no till here? So this graph is representing you what? Displacement. It does not represent the distance. If the question is asked, represent the distance and time graph, then where the velocity first time became 0? Can I say here? All you need to draw the mirror image of this line. If I draw the mirror image of this line, then can I continue this as, consider this as your mirror? Then you should be drawing this like this. Okay. I got my point. So from here to here, how much body traveled? Again 20 now. So can I say that this line will be represented by again extra 20, that is your 80. Are yes? Okay. Then again it moved in the downward direction. So can I represent this as like this? So till here it moved. Okay. Then next, again at this point velocity became 0. Again you have to add one more mirror for this one. Are yes or no? So take this and substitute over there. So how much body traveled? Now the body traveled like this. Now let us see how much body traveled in our graph with the distance also. From here to here it traveled 40. Then from here to here again 20. This one is 20 now. So can I say 40 plus of this 20 plus of this 20 plus of this 20 and plus of this 20? Are yes or no? So 20 plus 20, 40, 40 plus this 20. How much? 60, 60 plus this 20, 80, 80 and this 40, 100. So can I say distance and displacement both are equal till here, till this point. Till here distance and displacement are equal. But from here displacement moved in this direction and distance moved in that direction. I got my point? Yes or no? So that is your displacement time graph. Some will draw the exact mirror copy of this one. You can also draw like this also. Okay. Now the next thing, acceleration time graph. Okay. From A to B, velocity is constant. If velocity is constant, then what will be the acceleration? Can I say 0? Acceleration is what? 0. So if acceleration is 0, then there is no value. So A to B acceleration is what? 0. Okay. The next thing, B to C velocity is decreasing, increasing, decreasing. Who will decrease the positive velocity? Obviously negative acceleration. So from here to here, let's say this point is C. Okay. Then again C to D. C to D. Who will increase negative velocity? Obviously negative acceleration. So C to D also can be represented like this. So this is 0 time, this is 2 seconds, this is your 4 second, this is your 6 second. Now where is the body? At D. Okay. Then again negative value is decreasing. Negative velocity is what? Decreasing. Who will decrease the negative acceleration? Yes, very good. Positive acceleration. So from here the acceleration is positive till what? More 2 seconds. So this is your 8 seconds. Then again positive value, positive velocity is again increased, definitely positive acceleration. So from here to here, again this is still 10 seconds. I got my point. If I want to represent this on number line, the same graph can be represented on the number line, then can I represent body started from 0, moved till 40, moved till 40 meter, then again velocity got decreased, so it again moved for more 20 meter. Now the position of the object is at 60 meter here. Then from 60 meter body returned the path and moved how much? More 20 meter by increasing the velocity till here. Then from here again body started to decrease for more 20 meter till here. Can I say that? Okay. Then again velocity became 0. Again the body traveled more 20 meter. That means from here to here. So can I say that at this point velocity became 0 and at this point velocity became 0? Can I say that? Yes or no? Very good. So how much body traveled in reality? This 40 plus this 20. 60, 60 plus of this 20. 80 and this 20. 100 and this 20. 120. This is the total distance traveled by the body. From here, can I say that this is your initial position and this is your final position? How much body traveled from here to here? Obviously traveled 40 meter. That also been represented here. Got my point? Right on. Okay. So we need to find acceleration also, na? So from here, from the graph, so can I say that this is your final position and this is your initial position? So final velocity is 0, initial velocity at this point is 20. So 0 minus of 20 minus of 20. How much time it is taking? 2 seconds. Then the acceleration will be minus 10. So at this point acceleration is minus 10 meter per square second, and at this point acceleration is 10 meter per square second. Here is the positive value, here is the negative value. Okay. Right on now. Okay, shall I? Example number 2 on again this same topic. but this time the graph is given in a different way. Let us consider, so A is nothing but, can I say dv upon dt? Can I say that? Can I also say that this A can be written as a dv is equals to a dt, or if I integrate this, this becomes v minus of u is equals to a dt. Can I write like this? So can I say that area under the graph of acceleration and time will provide you velocity? Yes or no? So can I say that AT graph and the area under it will provide you what? Change in the velocity. Okay, now let us try to understand this by example. Now the example is like this. Consider it is going over here. This one is your acceleration, this one is your time, and let's say this value is 2 seconds, this is 4 seconds. Let the acceleration will be 10 meter per square second. Okay, now listen to me. What I said, just area under AT graph will provide you change in the velocity, and given that at t is equals to, let's say at t is equals to 0 second, u is 6 meter per second. Okay, now listen to me how to do such things. So what is the area in this one? Can I say 10 into this 2? This becomes 20, and this is 10 into this 2. Again, this becomes 10. So what is the area under the graph? 30. So area under the graph is nothing but a dt is nothing but v minus of u. Yes or no? Yes or no? And this value we got how much? 20 plus of this 30. 10. That is 30, which is equals to final velocity. We don't know. Initial velocity is given 6. Then v is equals to 36. Can I write like this? Yes or no? No doubt. So whenever you will be finding, now listen to me. Whenever you will be finding AT graph and the area under the curve will provide you what? Velocity, and especially the change in velocity. Got my point? Okay. Now you can note down. Okay. Now the next type. Sometime they will provide you AX graph. Okay. They will provide you what? AX graph. Now listen to me first. Definitely on the y-axis A will be there, and x-axis X will be there. Displacement. Okay, we already know that. Can I write v square minus of u square upon 2 is nothing but Ax? Can I write like this? Yes or no? Can I say that area under Ax graph will be given by v square minus u square upon 2? Okay. The question is let the same graph consider like this. Consider acceleration at this point is 10 meter per square second, and this one is 2 meters, and this one is what? 4 meter. Given that at x is equals to 0, u is 2. Find v. Find what? V. Then how we generally attempt such kind of questions? What is the area over here? Can I say this area is 20? Again, this area is 10 and this 10. Yes? Yes or no? So generally the area what we got? 30. Do we have initial velocity? Yes. Can we find the final velocity? Obviously yes. So can I say this 30 is equals to v square minus of 2 square upon 2? Yes or no? Or can I say that 30 into 2, that is 60, and minus 4, this becomes 4, which is equals to v square, or v is equals to under the root of 64 meter. Yes or no? We can do the answers like this. Okay, and one more, the last type is Vx graphs. Okay, consider. And on y-axis v, on x-axis x, given like this. And at this point velocity consider v naught, at this point displacement is x naught. First listen to me, then we will make a equation. Then if you want to memorize that, you can memorize. Okay, generally what this slope is, can I say this is having a negative value, m is negative here. And how we write m? M is nothing but y upon x now. Who is on y? Can I say v naught is on y? Who is on x? Can I say x naught? slope is negative, so m. Generally straight line slope is represented by y is equals to mx and intercept is positive now. So minus mx plus of c, slope is negative, so that's the reason here is the negative symbol. Okay, now substituting the value, who is on the y, that means can I say v? So v is equals to minus times of m value is v naught upon x naught into x, and c value, who is on c? Intercept, can I say v naught? So this is your y intercept c, and slope is already given. So in terms of c, I can write what? V naught, or can I also integrate this? If I substitute in what? Acceleration. If I substitute in what? Acceleration equation, then acceleration is nothing but v dv upon dx. Do we have this equation? So if I substitute acceleration, v is what? Minus times of v naught upon x naught into x plus of v naught. This is your v value, and differentiation of v naught again minus v naught upon x naught x plus of v naught upon dx. Can I write like this? And a is equals to, can I write minus of v naught upon x naught into x plus of v naught. This one is remaining as it is, constant, and if I differentiate this, this becomes 0, and over here it becomes minus v naught upon x naught. Yes or no? Multiplying that by, so a is equals to, can I write minus times of, oh sorry, minus into minus plus, so v naught square upon x naught square into x plus of, sorry, minus of v naught square upon x. So with this equation, can I calculate the acceleration? Let us try, don't write anything. Let us try to have one example. Consider on this one v is given, on this x is given, and a straight line slope is being given. Consider over here the value is, let me be 10 meter per second, and displacement is at this point, let's say 20 meter. They can ask you what? Find the acceleration at position, let's say 5 meters. What will be the acceleration at this point? Then we can use this equation by, so acceleration is equals to acceleration v square. What is the v naught value here? 100. So v naught is 10, so v square becomes 100 na beta. So 100 upon x naught value, that is 20, that is 20 means 20 into 20, that is 400, and x, this x is the given position where he is asking. So value is 5 minus of v naught again, can I say 100 upon this 20. Can I write like this? And cancelling that, this becomes 5, and this is 5 by 4. Can I? So acceleration is nothing but 5 by 4 minus of 5, then acceleration is 520, that is minus 15 upon 4 meter per square second. This is how we calculate. Are you got my point? So these are the basic and different type of questions we can attempt with Vx graph, AT graph and AX graphs. Okay, note down.